This is exam 1 for Physics 101, Fall 2015. This is the 4M version. Mid-sized car has an approximate volume of which of these? Well, a mid-sized car is approximately 5 meters long, about 15 meters, 15 feet long, rather. It's about, it's about 2 meters wide, and then if you think about how tall it is, it goes up to maybe almost 2 meters, let's say 1.5 meters. So it's going to be 2 times 5 times 1.5, so 15 cubic meters. It's definitely not any of these others. Those would be very large cars. A guy in a kayak can travel approximately what distance in 10 minutes? Well, let's see, it can travel about 1 meter per second in a kayak, and in 10 minutes, that is, 10 times 60, that's 600 seconds. And so the seconds cancel only with 600 meters. Which of these equations is dimensionally correct? Okay, let's start with this first one first. I have meters squared per second squared equals meters squared per second squared plus meters per second squared, that's acceleration. X is meters, and so yes, all of these are correct. I get a meter squared over here from these 2 meters. Let's try this other one, 1/2 mv squared. Oh, well, let's see, I could just stop right there actually. It's either A or E. Well, let's try 2. So I have kilograms meters per second squared plus meters kilograms meters per second squared. Oh, and I'm sorry, this should be actually meters squared per second squared. So far we're okay. These two check out. Let's look at this last one. M is kilograms, x squared is meters squared, 1/t is seconds. So here I'm missing a second, so the answer is going to be A for number 3. Consider this equation. There's the units for the variables. What must be the units for B if it's dimensionally correct? I can just forget about this stuff. And then I'm going to cancel some stuff. I'll cancel out these M's, and I'll cancel out these V's. So I'm left with 1/seconds on this side, V, and then I have seconds squared per meter. That's 1/A. So in order to make this seconds, I'm going to need meters here to cancel with that, and then I'll need a seconds cubed in order to cancel that and give me 1/second. So I need a meters per second cubed. B is the right answer. What is the proper solution in decimal notation of this calculation? Well, if I put this in my calculator, I get this. Let's see, I'm going to do this multiplication first. I have 3 significant figures, so this number would have 3 significant figures, and then this also has 3. So my final answer should have just 3 significant figures, so it should be 8.47. C is the right answer. Which of these is standard of measurement for the meter? It's the distance that light travels in a particular amount of time. Fraction of the Earth's orbit bar in France. It is going to be A, the distance that light travels on a particular amount of time. What is the angle theta here? Okay, well I know the opposite and adjacent side, so I just say the inverse tan of opposite, excuse me, 3.1 divided by 8.5. I get 20 degrees. D is the right answer. Consider the triangle. What is the length of the hypotenuse? Okay, well I just say the square root of 3.1 squared plus 8.5 squared. I get 9 meters. Acceleration is the rate of change of velocity. Car accelerates at 12 meters per second squared. What is this in miles per hour squared? So 12 meters per second squared. I will put this conversion factor, give it to you, but in 1 mile there are 1609 meters. That would be given to you. And then in 1 hour there are 3600 seconds. And this has to be squared because I have this squared over here. So that's 12 times 3600 squared divided by 1609. I get 8,000. Let's see, did I do that right? 12 divided by 1609. Oh no, I get 97,000. 9.7 times 10 to the fourth, that is B. European sports car dealer claims that his product will accelerate at a constant rate from rest to a speed of 100 kilometers per hour in 8 seconds. What is the speed after the first 5 seconds of acceleration? Alright, so first I want to convert this into meters per second. So I have 100 kilometers per hour, 1 hour, 3,600 seconds. 1,000 meters in 1 kilometer. So that's 100 times 1,000 divided by 3,600. I get 28 meters per second. I'm keeping one additional sig fig there. We'll just sort of hang on to it for a little bit. Actually, no, let's see. I'm going to keep this as 27.7 meters per second, and then I'll come back and put this with 3 sig figs. Pause here for just a second. Okay, so my first thing here is to find the acceleration. Let's write my kinematics equations. I'll write them right over here because I'll probably use them again anyway. V equals V naught plus AT, and then X is V naught T plus 1/2 AT squared. And I want to find the acceleration. This is my final velocity. I also know that V naught is equal to 0 because it starts at rest. And I know that it gets to this final velocity in 8 seconds. So T is equal to 8 seconds. Alright, so if I want to find my acceleration, I use this one. I'm going to solve this for the acceleration. That's V minus V naught over T. Alright, so that's going to be 27.7 minus 0 divided by 8 seconds. I get 3.46 meters per second squared. Alright, but then there's a second, that's not the answer. I want to know what is the speed after the first 5 seconds of acceleration. Alright, so after 5 seconds of acceleration, I want to know its speed. So I'm doing this again. I say V equals V naught plus AT. V naught is 0. I want to know what V is. It's going to be 3.46 meters per second times my time, which is going to be 5. So it looks like 17.4, I think. Yeah, 17.4. I get 17.3. I might have carried my sig figs a little bit differently. So I'll make that change. So it'll be 17.3 for number 10. All right. That was probably one of the more difficult questions. Number 11, a ball is pushed with an initial velocity of 4 meters per second. The ball rolls down a hill at a constant acceleration. The ball reaches the bottom of the hill in 8 seconds. What is the ball's velocity at the bottom of the hill? This one's very similar. I have this ball. It has an initial velocity equal to 4 meters per second. It has an acceleration equal to 1.6 meters per second squared, and it reaches the bottom of the hill in 8 seconds. I want to know the velocity. Okay, so I just say V is equal to V naught plus AT. That's going to be 4 plus 1.6 times 8. Like 16.8 or 17 meters per second. So A is the right answer. You throw a ball up with an initial speed of 30 meters per second. How long does it take for the ball to return to your hand? Right, so I throw this ball, it goes up and comes back down again. I know that at the top the velocity is equal to 0. I also know that the acceleration is minus 10 meters per second squared, and that V naught is equal to 0. I do not know how far it goes up, nor do I know the time for it to go up. I'm going to call the time for it to go up, call that T top. I don't know that, but I do know that at T top, at the top of the trajectory, that the V is equal to 0. So I can say V is equal to V naught plus AT, and I solve for T. I'm going to put this at the top and this at the top. I'm solving this for the top of the trajectory. I know that this is equal to 0, And oh, I'm sorry here, my V naught is 30 meters per second. So I say 0 equals 30 plus negative 10 times T top. So I know that it takes 3 seconds for it to get up to the top. So T top is equal to 3 seconds to reach the top of the trajectory. How long does it take for the ball to return to your hand? Well, that's going to be twice the time. So it's not 3 seconds, it's 6 seconds to return to your hand. You throw a ball up with an initial speed of 30 meters per second. What is its maximum height? Notice this is the same problem. I already know that T top is equal to 3 seconds, so I'm just solving for y. Y is equal to V naught T plus 1/2 AT squared. All right, V naught was 30 meters per second. T is 3 seconds. Notice I'm using T top because I want to know it travels up and then back down again. I want to know what is this. So this height, and so at that height, T is equal to 3 seconds. So that's what I use. That's why I use T. By the way, T equal to 3. By the way, if I put in T equals 6, I would just calculate 0. If you don't believe me, you can try it out. Because that's its position at 6 seconds. All right, so this is 90 minus 5 times 15. 5 times 15. 5075. So that's 15 meters. A is the right answer. You and your dog go for a hike. You walk on the path that your dog runs all over, crossing your path many times. Your dog's average velocity is equal to your average velocity because he has the same beginning and ending points. Even though he changes a lot, he still changes his speed a lot, he still has the same beginning and ending points. Remember, average velocity is just delta x over delta t. You throw a ball in the air, it requires 10 seconds to travel to its maximum height. How long does it take to return to your hand? All right, it takes the same amount of time. Remember, those things are symmetrical. If the velocity of a car is non-zero, can the acceleration of the car be 0? Absolutely, yes. So that would just be, if the acceleration is 0, that just means it's moving at a constant velocity. Which of these statements represent the motion in this plot? Well, let's see. It's negative velocity. So I'll get rid of these two. And the slope is small here and big here. So the slope is increasing. That means it's speeding up. So an increasing negative velocity. By the way, this would also have a negative acceleration, an acceleration that's in the same direction as the increasing velocity. What about this position versus time graph? Which of these velocity versus time graphs represent the same motion? Well, let's see. I have a negative slope here, so it's going to get rid of this one and this one because my velocity is initially negative, and then my velocity gets bigger with time, so it's going to get rid of this one. So it starts out small and in the negative direction and increases and gets bigger in the negative direction. So A is the right answer. So the following graph was the velocity at t equal 8.5 seconds. That's right here. I just want to know, what is this slope? I do rise, which is 15 to 0. My rise is 15 over run. It's going to be 1. Let's see. I'll have to come back. It should be 15. Oops, sorry about that. Should be 15 meters per second. Pause here for just a second while I make a note of that. Okay, consider the graph in the previous question. What is the average velocity between points E and H? Remember, average velocity is just delta x over delta t. E and H is between 11 and 6 seconds. At 11 seconds, it has a position equal to, looks like it's 14 or so. E is negative 16, so it's going to be 14 minus the initial minus a negative 16. 14 minus negative 16. So 30. 11 minus 6 is 5. 6 meters per second. And let's just double check, it should be positive, right? Yeah, I'm looking for the slope of this line, and that is a positive slope. All right, number 21. A car begins at a velocity of negative 30 meters per second and ends at a velocity of minus 50 meters per second. Which of these position versus time graphs represent this motion? When it starts with a small negative velocity and ends with a big negative velocity, first of all, I'll get rid of this one and this one because those both show positive velocity. Starts with a small negative velocity, ends with a big negative velocity. So C is the right answer. What distance does this particle travel between t equals 0 and 4 seconds? I'm going to change this one a little bit, so your graph might look a little bit different from this one, just to make it a little more clear. But between 0 and 4 seconds, I just want to find the area between these 2 points that's underneath this curve. Notice that in this case, each of these blocks has an area of 1 by 1. 1 unit here, 1 unit here. So each block corresponds to 1 meter. So I'm just going to count the blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll count this one and this one as 10. I'll count this one and this one as 11, and I'll count this one and this one as 12, and I'll count this one as 13. It looks like about 13, 14 meters or so. Yeah, C is the right answer, 13 meters. All these others are obviously not the answer. Just finding the area. Consider the graph in the previous question. What is the acceleration at 3.5 seconds? All right, well, at 3.5 seconds, that is right here. I want to find the slope of this line. You might draw a slightly different line there, but I want to find the rise and the run. In this case, I can just count the squares. 1, 2, 3, 4, 5, and run is 1, so it's 5. Notice that the slope is negative. Oh, look here, I actually used, when I wrote the question, I got a different thing, so obviously, let me clear this out. There is some judgment call on the tangent line that you draw, since we're just sort of estimating it by feel. So let's see if I can recreate that. Well, if I draw my tangent line, I'm going to sort of fudge it a little bit. Yeah, you get the idea. It should go something like this, your tangent line. Anyway, it's going to be close to 5 or 6. And obviously, all the other ones are not correct. You can get rid of A and C, and B and E are much, much too steep. So D is the right answer. The vector has a magnitude of 12 and is 20 degrees above the x-axis. What is the y component of the vector? So here I have 12 units. It's 20 degrees above. I want to find the y component here. The y component of this vector is equal to 12 times the sine of 20. That's going to be 4.1 meters. D is the right answer. And consider these two vectors. What is the magnitude of their sum, a plus b? Okay, I have A is 11 units along the x-axis. This is the vector A. And then B is 24 units at 60 degrees above the x-axis. So let's find Bx and By. This is A equals to 11. Bx is 24 cosine of 60, and By is 24 sine of 60. So this is 12, of course. 24. This is 21. So my Bx is 12, and my By, which I'll draw right here, is 21. So if I redraw this as a triangle, I get a triangle that has a side here of 33, that's 11 plus 12, and a side here that's 21. What am I looking for? I'm looking for the magnitude. So I'm looking for the hypotenuse. So the square root of 21 squared plus 33 squared. I get 39. Hold on. I get 39. Let me see if I made a mistake here. I might have a mistake on this one, in which case I'll change it. A is 11, 24. Okay, that's correct. I'll have to come back and change this one, but let's see, the right answer should be the square root of 21 squared plus 33 squared. I get 39 meters. I'll change that on the test with the right answer. I'm not sure what happened there. All right, so all right, almost done here. Consider these vectors. What is b minus a? All right, remember I want to flip this vector a. So I first draw b, and then I draw the vector a. I'll just draw b right here, and then the opposite of vector a. And so my resultant will look like this, and that's going to be c, obviously. Vector has positive x component, negative y component. So the x component is here. The y component is here. The magnitude of the y component is bigger than the x component. That means y is going to be like bigger, and so the resultant vector will be like that. Which of these is the only appropriate angle for this vector measured from here? Okay, well this vector has to be somewhere in that fourth quadrant. It has to be between 270 degrees. It has to be bigger than 270, and then it has to be less than 270 plus 45, so it has to be less than 315. So somewhere between 270 and 315, that's going to be E. And then, of course, my favorite student is U. All right, so that is the end of that exam. Obviously, with a few changes, I'll correct those errors.